You want to run through three of the methods we have to solve quadratic equations. This is the second type of equation we've run into. We already solved linears. So now we're moving on to quadratics. There's three methods. We'll kind of go through. The first two it will not work all the time, and we'll see when it works, when it will not. The third method, using the quadratic formula, is the one that will work all the time. Okay. So in this first one, you're asked to use the zero product property, which again means you're going to try to factor it. And if you can factor the polynomial, then we know numbers multiply to be zero only if at least one of them is zero. Okay, so the key here is if it factors. Okay, now again, keep in mind this is zero product property, so you have to set it equal to zero. Okay, so in this first one, it's all set to go. We're just solving, it's a degree 2, right? It's equal to 0, so we're going to try to factor. So remember, when you factor, you look for a greatest common factor first, which in this case would be a 2. You're left with x squared plus 2x minus 8. And then you're trying to do this reverse FOIL. So x squared had to come from x times x. And again, remember, you need to what numbers multiply to be negative 8 and add to be positive 2, which is positive 4 and negative 2. Okay, so since it did factor, the zero product property is working well. There's actually three factors here, three parts being multiplied. Where factor means expressions being multiplied, which means the only way this can be 0 is if one of these is 0. Well, clearly 2 can't be 0, so either x plus 4 is 0 or x minus 2 is 0. So that gives us two solutions. All right, so number 2, it's not an equation to solve. You're just given a function and asked to find the zeros. Well, remember, the zeros of a function are when the output is 0. So you want to know when the function equals 0. So this is just another way to say solve when this function, x squared minus 6x plus 9, equals 0. Okay. So again, we'll try to factor. The GCF is 1, so we're going to go right to this reverse FOIL. Okay. X squared is the x and x, and again, multiply to be 9, add to be negative 6 is negative 3, negative 3. Okay. When numbers multiply to be 0, one or the other has to be 0. Okay. This one obviously gives us the same solution both times. This is what we would call a repeated root or repeated 0. Okay, so we've already seen actually a couple possibilities, two different zeros for quadratics, or you might get the same 0 twice. Okay. We'll see other possibilities going forward. All right, again, just a slightly different question, but the same work we're going to have to do. Find the x-intercepts. Remember, the x-intercepts are somewhere along the x-axis. Okay, so again, what do we know about points along the x-axis? It has to be something common 0, so the y has to be 0. So again, this is just another way to say, when is this function equal to 0? Okay, so again, we factor, take out an x here, GCF is x, so we have 5x plus 3. All right, they're both linear terms, so we're good to go. Okay, so either the x is 0 or the 5x plus 3 is 0. Okay, this one's done. This would be x equal to negative 3/5. So again, two zeros there. Okay. Sometimes for x-intercepts, we like to write them as points. So maybe you could say 0, 0. And the other one we found was negative 3/5, 0. Okay. All right. Second method is this, using the square root property. Okay. And again, this is useful when you have no, what we call linear terms. So if you remember, the ones on the front had an x squared, an x, and then a constant term. X squared, an x, and a constant term. Okay. It has to have an x squared or it's not quadratic. When it has an x term, that's when the second method doesn't work. Okay. But if it only has this quadratic square term and a constant, then you can use this second method. Okay. So you can see clearly in these first two, right, there is no x term. All right, so what do we do? Well, since there's not x squareds and x's floating around, we just isolate the x squared. Okay, so it almost feels like how we would do a linear one, but we're not getting x by itself, we're getting x squared by itself. Okay, and then we'll just need to square root. Okay, so we'll divide by 2 here. So x squared is negative 5, and then we can square root. Just remember, when we take square roots, it's plus and minus. Okay, and then we clean this up a little bit, so we can at least take out that negative 1 as an I root 5. Okay, Okay, so keep in mind these are two imaginary solutions. Okay. Second, again, when there is no x term, you can just isolate the x squared term, so get it by itself, and then square root each side. But again, just be careful you do plus or minus. So again, these are irrational, but those are two real zeros, or two real solutions for that equation. Okay. Third one is a little bit different, okay, but it's still nice to kind of use this method because I don't have an x squared, but I have a parenthesis squared. Okay, but we can still use the method by isolating the parentheses. So I'm going to divide out that 2. Okay, so again, it's not an x squared, but it's parentheses squared, so I square root. That gets rid of the square. Again, just be careful you do plus or minus. Okay, now we don't have x yet, so I just have to add that 1. Okay. It's much easier to do it this way than square this whole thing out. And what you would, I don't think it would factor, so you'd have to use quadratic formula. So again, parentheses squared is kind of nice. If you isolate that parentheses squared, you could still square root each side. You'll just have this extra step at the end. Okay. All right, sometimes neither of those works. So we have our third method, which is the quadratic formula, which you do need to memorize. It comes from completing the square and that square root method. Okay. Let me just write this here so we remember. So if our equation is ax squared plus bx plus c equals 0, okay, so again, a represents the coefficient of x squared, b is the coefficient of x, c is the constant, equal to 0, then our roots or zeros, or solutions to that equation, are the opposite of b, plus or minus square root b squared minus 4ac all over 2a. Real important that you memorize that. Okay. All right, so in the first one, again, it doesn't look anything like ax squared plus bx plus c, so we have to distribute. We have to get 0, so we're going to have to bring these over here. So I'll subtract the 2x over here, that'll become minus 4x, add the 2 over. Okay. We clearly can't use the second method, the square root method, because we have the x term. If we try to factor, it fails. There's no two numbers that multiply to be 2 and add to be negative 4. So our choice here now is the quadratic formula. So a is the coefficient of x squared, which is 1. B is the coefficient of x, which is negative 4 in our case. And c is the constant. Okay. So x equals. Now again, I do a couple things here. So the opposite of b I do in my head. So the opposite of negative 4 is 4. Plus or minus square root. I also square this in my head. So b squared is 16. The rest I'll just write 4ac. Remember, that's all over 2a. Okay. So this is 4 plus or minus 16 minus 4 times 2 is 8 over 2. All right, and we get 4 plus or minus the square root of 8 over 2. And then we usually clean this up a little bit. 8's not a perfect square, but remember it has a perfect square in it. So we could take out a 4. So think of that as 4 times 2. There's a little bit more cleaning up here. So the square root of 4 is 2. Okay, now be careful. We have a sum or difference on top. So we don't cancel these, but we can factor out a 2. Okay, so just a little bit more cleaning up. So I'll take out a 2. That's 2 plus or minus root 2 over 2. And these will cancel. And we're left with 2 plus or minus root 2 for our two solutions. Okay. All right, and then in number 2, again, we could try to factor. It will not factor. So again, I'll have my a to be 2, b to be negative 1, and c to be 4. So by the quadratic form, it's the opposite of b, so that's positive 1, plus or minus square root b squared, which is 1, minus 4, a is 2, c is 4, all over 2a. So that's 1 plus or minus 1 minus, that's 32, all over 4. So that's 1 plus or minus the square root of negative 31 over 4. And again, the only thing I can do here is you want to take out that negative square root as a I. But otherwise, there's nothing really to clean up there.